I want to welcome you here to the last session of Lync conference. You made it. Fantastic. This is high availability and disaster recovery. This will be a 400-level session on HADR, so we're going to get pretty deep in how some of these components work. My name is Brian Nice. I'm an architect in Microsoft Communication Services, Microsoft Consulting Services, Enterprise Communications COE. The name is such that they can't give me a business card because it would be like this long. So, my job here is to take you guys through what high availability and disaster recovery means to us in Lync, what the features are, and then essentially dive headfirst into the supporting technologies that we have for HADR. Terms that I'm sure you've probably heard or read about, things like fabric and pool pairing and mirroring and all those fun things, right? So kind of dig deep into that, see what's going on under the hood, and kind of tie that back into our design implications, right? So once we get this grandiose knowledge, what does that mean when I go to build and architect and design a Lync solution? So some takeaways here, we want to be able to compare and contrast the technologies that we use for HA and the ones that we use for DR, right? Because we want to be very crisp in our messaging as to what we really mean by HA and what we really mean by DR. And then we want to understand what the operational and design impacts are going to be, right? Design impacts, pretty straightforward, right? Operational impacts, that's pretty key, right? We need to know how to properly operate these technologies so that we don't inadvertently shoot ourselves in the foot and cause an outage when we were trying to prevent one while we were doing maintenance. So quick slide about me. I live in Mission Viejo, California. It's in Southern California. You can see in the middle there, that's my SIP address, my email address. So you can find me on Lync or shoot me an email. I am part of the Masters community, Microsoft Certified Solutions Master on 2013, as well as a Certified Master on 2010. Also helped to develop a lot of the curriculum for the now defunct Masters program. But it was a lot of fun when we did it. And you can see in the top right, in my spare time, I like to make a lot of noise. I don't know how my parents survived, but hey, it was great. So we have a lot of content to cover here. So I'm going to spend a brief amount of time going through a quick overview of HA and DR, and that's really just to kind of level set terminology, right? So they're all speaking the same language, if you will, when we start to get a little deeper into the HA and the DR pieces. So first and foremost, we have to separate out the difference between high availability and the disaster recovery, right? Because depending on who you ask, everybody has a different definition of what that is, right? So you say, oh, it's highly available. It means that it's available from site 1 that's in San Francisco to site 2 that's in New York. Yet no, that's not high availability to us, right? That may be high availability to you. That's disaster recovery to us, right? So there's a simple way to remember it. When we talk about high availability, or HA, in the Lync world, that's inside of a site. So any technologies that I talk about under the HA umbrella are meant to be deployed inside of a single site, single geographic data center. So when we're doing HA, we have two pieces to look at, the server piece, the back-end piece, right? The server failure piece, things like building a pool, doing DNS load balancing, doing fabric, right? Those are all of the server failure pieces that we have from an HA perspective. On the back-end side, that's SQL, right? So we have things that come into play like SQL mirroring, SQL clustering, SQL always-on availability groups, right? These are things that are going to protect us against back-end failure. So again, we're going to talk about that in the context of HA here. Keep in mind, those technologies that I'm talking about, that's HA, that's within a site. Okay, so don't think that you're going to take a SQL mirror and span it between data centers. That's not an HA technology for us, right? Spanning across sites is DR. Spanning across sites is not HA for us. Speaking of DR, the DR aspects for us are all about protecting failure of the pool itself and or failure of an entire site, right? And that's where that pool pairing concept comes into play. Now, there's a lot of pieces. I mean, it's a pretty busy slide. I'm not going to read everything to you. You can pull these slides down as a point of reference. But the two major categories here, protecting against pool failure, some of this isn't new to us, right? Back in the 2010 days, we could protect the voice workload against pool failure, right, with that concept of a primary and a backup registrar, right? So the primary registrar went offline. You would automatically register your backup, and your client would go into reduced functionality mode, and you could still make and receive phone calls. Woohoo, right? We've augmented that now in 2013 to be able to pair the pools together so that we can invoke additional modalities in the event of a failure. So now that pool goes down, we can run a couple PowerShell commands that you'll get to see, and voila, we have all of our modalities back. I have my buddy list, my contacts, IM, presence, conferencing, the whole shoot and match for the most part. A few little asterisks there that I'll talk about a little later, like response group and call park and so forth. But that is what is going to give us the layer of protection between physical locations. Okay, so that's DR from our perspective. Of course, protecting against an entire site failure, a lot of the same technologies, right? The pool pairing, or if you happen to be doing PChat, the stretched pool concept, right? But DR site failure also being able to have that geographically distributed data center and doing things like GeoDNS and whatnot to ensure that we can survive an entire site failure and not just a failure of the pool. To achieve these components, we had to change the model that we're using. In the Lync 2010 world, we had a very tightly coupled model between the front-end servers and the back-end database, right? And we say tightly coupled because basically a lot of the transactional processing was happening on the back-end SQL instance. So we were very constrained from an IOPS perspective, right, when it came to the Lync 2010 pool environment, because basically the back-end SQL database was just getting hammered, right, because that's where all the action was taking place, essentially. In 2013, we've moved into this concept of loosely coupled, where basically we've taken the load that was on the back-end SQL instances and put it on the front-end servers. Right? So you may realize, you look at the hardware requirements for a front-end server in 2013, you go, oh my gosh, I need 32 gig of RAM? I need all of that disk? Why do I need so much horsepower on the front ends? Because they're doing all the work now. The back-end SQL instance is a blob store, as we call it. It's basically a place where we can sync data back to and we can hydrate from, which we'll learn about in the next section. But a lot of the IOPS requirements are no longer on that back-end SQL instance. They're on the front-end servers now. Right? So now that's what's starting to give us this ability to expand out the size of the pools and get up into the 12 FE or more, right, model. So we're going to start with all these fun little pieces. We're going to start with the high availability aspect. That's the most fun for me, and you'll learn as we go throughout this presentation. My definition of fun probably doesn't align with a lot of people's definition of fun, but hey, it's fun, right? This is high availability. Let's talk about what we do inside of a site, and then we'll dig into what we do between sites. So let's pick apart the front-end HA pieces first. How many of you know or have heard of this concept called Windows Fabric? Okay, how many of you know exactly what it does and how it operates? Okay, probably a good idea to raise my hand, right? Sweet. I was thinking I probably wouldn't. Like, we'll figure it out together. No, probably when everybody gets up and leaves. So Windows Fabric is the replacement for a component we had in Server 2010 called Cluster Manager, right? Which it's basically the engine that we're using to be able to drive the high availability aspects inside of the pool. We're using this to do things like primary election, failover management, secondary election. I'm going to talk about primaries and secondaries as we go, so if you're a little spaced on that right now, it's okay. Understanding the primary and secondary aspects, doing replicas or replication between those and so forth. Essentially what it boils down to is Windows Fabric is there to give us that increased scale, right, to be able to support the number of users that we need, both from an on-premises perspective and into the online world. Right? So that's why we've changed the model from what we had before with the old cluster manager. Right? It just wasn't able to scale to the way that we needed it for both on-prem deployments, which are growing, and also the online environment. Now, most often what I hear from partners, customers, consultants, and whatnot when they talk about Windows Fabric is this concept of quorum. You know, I read somewhere on TechNet that I've got to have a certain number of servers up, in my front-end pool. What is that all about? What does that mean? That's a concept that we have called quorum. Okay, so in the Windows Fabric world, we have to achieve quorum for the Fabric to be able to properly initialize, and such for the front-end services then be able to properly start. So when a server starts or a server goes offline or what have you, there's a role called the arbitrator, which is basically the coordinator, making sure that we have the proper number of votes to be able to achieve quorum. And this chart that you see here, I pulled straight off of TechNet, which I'm pretty sure you guys are quite familiar with, right? And essentially, if you look at the chart, you can sum it up by saying, quite easily, I need 50% of my servers to be online in the pool to achieve quorum, right? I know it's a little tough math the day after the attendee party, but trust me, hit the I believe button, right? It is, it's 50%, right? So if I have a front-end pool of 10, I need to have 5. There's a little asterisk there too, right? On cold start, we need a little bit more than 50%. On cold start of the pool, we need about 85%. We'll get into that, but the general rule of thumb here is we need 50% up and running. Now, what does that mean? Well, let's say that I have that front-end pool of 10, and I take 6 of those servers offline. What happens to the other 4? Front-end services stop, right? Because we can no longer achieve quorum. We don't have enough servers online to maintain quorum. Front-end services stop on the remaining 4. That's bad, right, from a user perspective, right? Well, maybe it's good because it's time to go home, but it's bad from a serviceability perspective, right? So how do we determine voters, right? I mean, who's a voter? Well, obviously the front-end servers are a voter. But there's times where SQL comes into play as a voter too. And if you ever wanted to know who the voters are, you can go and check it out on the front-end servers. There's an XML file under C Program Data Windows Fabric, settings.xml, and you can actually see what the voters look like. Now, I've taken some screen caps here of what I've done in my lab as I expanded the pool out. And you can see at the top, I had the ever-popular 2-server pool. Yes, people say, you're not allowed to have a 2 FE pool. You've got to have at least 3. You can have 2. You can have 1. It's fine, right? Now, there's restrictions around it you've got to be aware of, which I'll get into a little later, but there's no problem having a 2-server pool. And if you take a look, you can see at the top there that the voters are pool A1, pool A2, and SQL. But we've got to have an odd number of voters, right? You can't have an even number of voters. If you have an even number of voters, who wins, right? We need a tiebreaker. Well, that's SQL. Notice what happened when I went from a 2 to a 3-server pool. Well, I don't need SQL to be a voter. I've got 3 front ends. Went back to 4. Oh, SQL's back into play. And you can actually see here, if you dig close enough, you can see that I actually have a SQL mirroring setup, if you look at the string there. All right, so that's all about achieving quorum. And that's important for us because without quorum in the fabric, the front-end services don't start or they don't stay running. And of course, we need that because the front-end service is the lifeblood for what goes on inside of Lync. So we got a little bit of quorum under our belt. What exactly is this fabric thingy, right? Well, the fabric actually breaks down into a couple of different components. We're not going to talk about every one of these components here today, but the components are MCU factories, conference directories, routing groups, and lists, right? Lists is the storage subsystem that we're using to be able to do fun things like shuttle data back into QoE and with our fun adapters and so forth. We're going to focus specifically on the routing group concept because that's where most of the action is. This is all about being able to maintain fast failover between front ends in the pool while still maintaining full serviceability. That's a mouthful. Sounds like a lawyer said that, right? Basically what it means is if I happen to be connected to front end 1 and it goes offline, I should be able to go to front end 3 and things should just work, right? Automatic. That's the idea of what the fabric is trying to do here. Give us that automatic scaling, give us that automatic load balancing. Now in the picture here, you'll see I've got a front end pool of 6. And on the right side, you can see I have 2 user groups, aptly named user group 1 and 2. Group 1, there's 3 copies of his data, right? Happens to be on the 3 servers that you see, 2 on the top, 1 on the bottom, with the little purple group 1. Same thing for group 2. He's on 3 of the servers, 1 of them up top, 2 on the bottom. Those are what we call replicas, right? So there's copies of my data on up to 3 front ends in the environment. One of them's my primary, the other 2 are secondaries. The users get mapped to these groups, right? So I, as a user, I have a GUID, a big funky number about that long, right? That's assigned to my user that says, this is your routing group ID. And now I know, okay, I've got 3 copies of data. I'm going to go to my primary. Each group then gets a persisted stateful service with up to 3 replicas. That just simply means that the fabric takes care of synchronizing your data between each copy on each respective front end. I get serviced by my primary replica. In the event the primary replica goes offline, one of the secondaries will become primary, and I'll get serviced by him, right? It's all automatic. That's the point of HA for us, and the fabric for us is it is automatic if it's configured and all set up properly, the right number of servers and so forth. It just simply works, right? And that's what we want from high availability, right? Disaster recovery, different story, right? Because disaster recovery typically means that something really bad has happened, and now I've got a series of steps that I need to take, maybe public DNS record changes and all these other things. I don't want that to happen automatically, right? This, if I take one server out, I just want somebody to use another one. I want life to be easy for me. So we get into this concept of group-based routing, which basically says that all of the users that are assigned to a particular routing group, you all get homed on the same front end. So that means if I have 50 users in routing group 1, and that routing group happens to have its primary on FE number 2, all 50 of those users are going to be using FE number 2, because we all go to where our primary routing group copy is. The groups will fail over to another registrar in the pool if the primary fails. What that means is we've got up to 3 copies, a primary and 2 secondaries. The primary goes offline, the entire group will just go to one of the secondary servers, and off we go. You'll get a chance to see this in a little bit with some PowerShell. Fabric takes care of rebalancing this stuff whenever we add or remove front ends to the pool. So I go from a 3 FE pool to a 4 FE pool. The Fabric will take care of going, oh, I see there's another front end server out there, and just redistribute the groups across the 4 front ends instead of it all being over 3 and one of them sitting there going, hi, got nothing to do, right? It'll just take care of rebalancing the load to that new front end server. And likewise, if we were to remove a front end, it would take care of that. And the routing groups are assigned to what we call a replica set. We'll get a chance to see that in the PowerShell coming up. So I guess the next logical question that typically pops into my mind is, okay, Brian, that's great. We have these groups. I'm put into a group, and there's like data replicated between front ends. What kind of data? What's in there? What's being replicated? Intrapool load balancing takes care of replicating all of your persistent user data. So my contact list, right? That information is replicated, and it's replicated in a synchronous manner. Okay, what that means is if I commit a change, that happens on all 3 copies simultaneously. Right? It doesn't happen on one and then kind of happen on the other 2 whenever it feels like it. No, it's synchronous. Right? And we need it to be synchronous because in the event that the primary goes down and I go to my secondary, I don't want to find out that I'm missing contacts because I had a lag in replication. Yeah, it's synchronous. Presence, contacts, groups, voice settings, conference information, right? That's all persistent data. That all gets replicated as part of the mechanism that the Fabric is using. If you're a SQL dude, there's a concept we use called deep chunking. That sounds pretty bad, especially after a long night out. But it's all about doing replication using deltas. That's more of a great, that's kind of the technology we're using on the back end. All you guys need to know is that we're not replicating full amounts of data, right? We're optimizing the way that we replicate. Transient user data doesn't get replicated. Right, so if my presence changes to, in a meeting because my Outlook calendar is blocked, for a meeting, and then that front end dies and that present state that changed to in a meeting didn't get replicated to another copy. Now, all it means is when my client connects to the new one, it'll connect and go, hey, I'm in a meeting, and it'll change my presence again, right? But it's transient. There's no real reason to replicate that information. There's minimal portions of conference data that gets replicated, right? We don't maintain an entire roster or the active conference MCUs. That doesn't get replicated. That information is actually in the backend SQL database, so we don't need to replicate that. The shared blob storage, that's the backend SQL database. We have limited use of that data, right? Most often what's happening is 2 things. One, we use it for hydration or rehydration, right? So I bring a front end up. And that front end is now responsible for these 5 routing groups. Well, he's got to go get the data for those 5 routing groups. Well, we call that hydration. And he'll go to the backend database and say, give me the data for these 5 routing groups. And he'll hydrate that data into his local SQL instance. And he's off and running. Right? It's also used in DR, right? When we're doing pull pairing and we're shoveling data across with the backup service, right? That gets pulled into the backend SQL blob, and then we can hydrate the front ends in the paired pool the same way that we hydrate the front ends on the main pool itself. So the replica concept There's always up to 3. And I say up to 3 because obviously if I have a front-end pool of 2, you don't have 3 copies. Yeah, no, you just have 2. So up to 3 copies. Always a primary, and then up to 2 secondaries. If one of these replicas goes down, another one will take over as the primary. Now, I have a nice little asterisk there because my favorite answer as a consultant is, well, it depends, right? It's always a great answer to use as a consultant. Another one will take over as the primary, but we may wait before we attempt to build another replica. Okay, so think about it. I've got 3 copies. My primary goes down. All right, so one of these other guys becomes the primary. So now I've got a primary and I've got 1 secondary. We may wait a little bit before we bring up that additional secondary copy. Now, why would we do that? Well, it's quite possible that the reason that this guy went down was I was doing normal maintenance, and the server's just in the process of rebooting, and it's going to be back up in about 5 minutes. So why waste all of that time hydrating another copy of all of that routing group data onto another front end when this guy's just going to come back up in about 5 minutes, right? Now, the fabric is pretty intelligent, I will say that, in the sense that depending on the number of users that you have on the pool and the amount of data, the fabric may actually realize that, you know what, it's not that expensive of an operation, and I'm just going to go hydrate it. Great. The point here is that if you don't see 3 copies right after you take something offline, be patient. Right? The fabric may just be realizing, hey, that's a pretty expensive operation. I'm going to wait a little bit and see if that guy comes back to life. And if he does, great. And if he doesn't, okay, then we'll go ahead and hydrate some more copies for you. Here's a little snippet of what it looks like. Oh, there's a question in the back. Yes. Is this configurable? Nope. So the short answer to that is no. The long answer to that is no. Okay. I have to credit my colleague Doug for that. That's not mine. I can't take credit for that joke. But anyway, this is not, the fabric takes care of all of this for you. It's the old I believe button, right? So here you can see I've run a PowerShell command here that's get CS user pool info for Amy, and you can actually see in the middle, it's the primary pool machines in preferred order. So I can see A1, A3, and A4. So that's her primary or secondary and her additional secondary. So I dump one of the servers, right? I can see, A1 has become the primary, and then A3 happens to be a secondary, but we haven't built another replica just yet. And then here we go. Not only did it build another replica, it actually decided to rebalance. Now, again, this is in my lab that has, probably about 11,000 users in the environment, but very, very small amounts of data, right? I don't have tons of data. So the fact that the fabric picked another one to be primary, you probably wouldn't see that in a larger environment, but the process is working as expected. Now, here's the fun part. What happens if when one copy is down, you lose another one? Uh-oh, right? Now you got a problem. Because if during the time one of the 2 replicas left goes down, the replica set is in a state that we call quorum loss. Okay, that basically means that you only have 1 copy of your data. We don't have 2 more copies around, and we are now in a state that's called quorum loss, which basically means that the fabric is going to sit there and wait forever to do anything till the admin intervenes. And I'll show you how the admin intervenes a little bit. Now, it's a protection mechanism, because if I've lost 2 of the 3 copies, I don't know if that 1 copy that I have left is kind of like stuck in a split brain scenario, and I don't really have the active copy, and it's not you, it's me, that kind of thing. I don't know, so I basically err on the side of caution and say, uh-oh, there's only 1 copy left? Quorum loss, sorry. And then it's going to be up to the admin to bring that back. We'll see in a little bit what that looks like from the user side, too. Right? So you have to keep that under consideration if you happen to lose multiple copies at the same time. Now, when we start up a pool, bring that thing to life, right? We've got to be able to maintain quorum. That's great. We have to create primaries for each of the respective routing groups. We have to sync the data from the blob to the local database. That's a process called hydration. Secondaries have to be elected and synced with the primary. Now, secondaries are synced with the primary. Secondaries don't get their data from the backend SQL and hydrate. Secondaries sync their data from the primary, right? So it's an FE to FE operation that happens. When you first cold boot this pool, you've got to have at least 85% of the pool around or the services won't start. Right? So lesson learned here, I had a customer that decided, hey, we're going to deploy a front-end pool of 6. But we only bought the hardware for 2. Well, they went into Topology Builder and they built out the pool with 6 FEs in it. And then they deployed 2 of them, and it never started. And they couldn't understand why it didn't start. So we kind of had to let them know, well, you don't actually want to define more front ends in Topology Builder than you actually have deployable, because you won't ever be able to achieve quorum. Because the fabric is going to look at the definition in the topology and say, okay, there should be 6 servers in this pool. I only see 2 up. Well, that's not enough to maintain quorum. I'll just wait, right? And that's good when you're billing by the hour, but it's not good when you're, when you're trying to get the services up and running. Now, on restart, right, Windows Fabric can load balance things to respective front ends, right? So a front end server gets patched, it reboots and whatnot. We may balance some more primaries to it, or it may need to sync and so forth. The 3 nodes have to be able to talk to each other, right? The 3 nodes that are the primary and the 2 secondaries, they replicate data between each other, right? So the front ends have to be able to talk to one another. So if you've got some crazy firewall admin that likes to kind of VLAN off all these things, make sure the servers can actually talk to each other. Otherwise, the replication between the fabric nodes isn't going to happen. So visually, it looks like this, right? I have a simple 5-node pool here. You can see on the bottom left, I have node 4 happens to be the primary for this one particular routing group that we're looking at. I've got nodes 3 and 5 over here as secondaries. Sweet. And now node 4, maybe we're patching it, rebooting, right? Maybe somebody was like, what's this button do? And down it went. But we're effectively now at a point where one of our copies is gone. In this case, happened to be the primary. So the fabric will promote one of the secondaries to primary. After a certain period of time, we'll elect another secondary, and we'll sync it with the primary to get them all back into a steady state, right? And that, in a nutshell, is how we're going to take care of getting this data replicated back and forth and getting the services synced, so that we have up to 3 copies of our data. So in the event I were to lose another front end, we could continue servicing our users. So far, so good, right? Yeah, sweet. But what about those pesky SBAs? How do they affect routing group placement? Because remember, when you define an SBA or an SBS, right, you have to associate that with a pool, right, for user services, because the survivable branch appliance or the survivable branch server, it's a registrar, right? They can register to it, but all the meat is happening with the associated pool for user services. Well, that means that the users that are placed on that SBS, they got to get put in a routing group, right, just like anybody else would. Well, here's the trick. When you define that relationship in Topology Builder between an SBS or an SBA and a Lync pool, we automatically create a routing group for all the users that are homed on that SBS or that SBA. So basically, everyone that's housed or homed on that SBS or SBA will always be in the same routing group, right? And the routing group idea is actually derived from the FQDN of the SBA. So think about that for a second. Everybody that's in an SBS or SBA is in the same routing group. Well, by our documentation, you can have up to 5,000 users supported on an SBS. That's 5,000 users that will all be in the same routing group. And what happens when you're on the same routing group? You're all serviced by the same front end. So now you have 5,000 people that are hitting front end 1 for their services. Okay, that's by design, right? You may be thinking, why would they do that? Well, when you're connected to that SBS, the SBS has to do heartbeats back to the user services to make sure the back-end pool is still alive, right? Well, keeping them in the same routing group means we only have to poll one of the front ends, right? If we let you split that up, then you may end up having an SBS having to poll all 10 of your servers in a front-end pool. That'd be a lot of chatter, so they opted not to do that. Again, it's a bit of a corner case because I don't have tons of customers that are deploying 5,000 users on SBSs everywhere, but you have to keep that under consideration when you're looking at the architecture and the design. So it looks like this. These are some screen caps that I got out of my lab. So first, I looked at my SBS user distribution here, and I can see that I had an SBS in my environment that had 1,001 users on it. All right, it had 1 user on it to start, and then I scripted 1,000. So Sorry for you OCD people that it didn't become 1,000 users, but it's 1,001 users. And I did a check of the routing group ID, and I just picked the first one, which are aptly named, Z user SBS 11 to Z user SBS 1000, and you can see that the actual routing group IDs are identical, right? I didn't actually go through every single one, but trust me, you hit the I believe button, right? The routing group IDs are all identical, right? All matching up there. So I went into my topology, and I decided that I was going to add another SBS to see what would happen. So first thing I looked and I said, oh, well, okay, these SBS users, yep, sure enough, primary is 3, secondary is 5, secondary is 6. This guy, same deal, right? So they're all exactly like I would expect, identical to each other. So I added the SBS to the topology. And first thing I did was I ran a little script here that I have that lets me see the routing group assignments to the map to the various FEs. So I actually have 6 front ends in this pool, and I've got routing groups that are actually tied to up to 5 of them, right? So I just recently added that 6th FE, and because I don't have a ton of load on this thing, we didn't really have to balance anybody to it. I went into Topology Builder, built a new SBS, published it, and voila, look what shows up. A brand new routing group ID, in this case tied to pool A6, which is where I would expect it to go, since it's doing absolutely nothing right now. But granted, I haven't assigned any users to this SBS yet, but that doesn't matter, right? Because the routing group ID is based on the name of the SBS. We've already created the routing group ID, and now I know anybody that's going to be associated to that SBS is automatically going to be placed into that routing group. Ta-da! And just in case you didn't believe me, right, there's and I'm going to go through these PowerShell commands in a little bit, but there's my routing group user distribution script that I ran, and I can see for that I scripted another 5,000 users. Make the OCD people happy, nice even number, right? Does that routing group ID look familiar? Right, it should, because it's that one, right? So the routing group ID is there. I check one of my users. Sure enough, he's assigned to that routing group ID, and there you can see, in this case, he's got primary pool is D2 because that's the SBS itself. That's his primary registrar, right? Backup pool in preferred order is 6, 4, and 3 because that's where his user services are located. So don't forget about our friend the SBS when it comes into the Fabric world. All right. So that's great theory. What do I do with that? How do I manage this thing? What do I have to be thinking about when I'm managing a front-end pool that has all of these copies of data, and I've got primaries, and I've got secondaries, and I have a certain number I keep online, and I don't want to, my head's going to explode. What do I do, right? Well, first off, to understand management of the Fabric, we first have to talk about a term called the upgrade domain. Now, you may have seen or may have poked around a little bit inside of Lync and realized that there's this concept called upgrade domains, which is essentially, as stated here, it's a logical grouping of servers on which software maintenance, such as upgrades and security patches, would be performed at the same time. Well, essentially what that means is when we build out your pool of 6 FEs, right, we're going to determine upgrade domains for you. The idea being that when you go to do patch management or maintenance on a system, you would perform maintenance on one upgrade domain at a time. Now, that upgrade domain could contain 1 server, it could contain 2 servers, it could contain 4 servers, right? And I'll show you how you can see that in a little bit. But the idea is that the upgrade domain is your unit of administration. It's your unit of management, right? So when I'm going to go and do patch management for a front-end pool, I don't patch all 6 of them at the same time and reboot. Not a good idea, right? Career-limiting move if you decide to do that. So we want to, what order do I patch them in? What is safe to take online, offline, all that good stuff, right? Now, how are upgrade domains determined, right? It's determined by Topology Builder at the time you build the pool, right? So if I build a pool of 3 front ends, I get 3 upgrade domains, right? And then I add another one, I get another upgrade domain. I add another one, I get another upgrade domain. I build a pool of 14 FEs, I get an upgrade domain of 6, and then 1 and 2. And it's got an algorithm that it uses internally. You don't need to know necessarily what that algorithm is. You just need to know that there are ways for you to see what that routing group breakdown is. Thus, you will know what is the unit that I use to do this proper patch management. Now, upgrade domains are also important for the fabric when it goes to place copies of your routing group, right? Because it would be a very bad idea to place your primary, your secondary, and your other secondary all in the same upgrade domain. That would be bad, right? Because then we take that upgrade domain down, and what happens? You lost your services. We don't want that, right? So the fabric is smart enough to realize, hey, I've got 3 upgrade domains here, 2 nodes in each upgrade domain. So I'm going to put a primary here, a secondary there, and so on and so forth, right? So one too many. So the fabric will take care of placing all of that for you so that in the event that you take an upgrade domain offline, you're not knocking out multiple copies of a particular routing group, because that would cause the routing group to go into or the replicate set to go into quorum loss, and then you'd have a service outage for that subset of users. We don't want that. Now, the flow chart that's here, it's an eye chart. I don't expect you to read this. It's straight off of TechNet, right? But essentially, to sum up, what this says is when you're going to upgrade your front ends, and by upgrade we mean apply a patch, a CU, right? So we release a February CU or something like that. That's what we mean here. How are we going to patch these front ends? Well, 1 upgrade domain at a time. So you use the commandlet get cs pull upgrade readiness state. That will tell you what your upgrade domains are and which servers are in which upgrade domain. Then you pick 1 upgrade domain and you start patching it. Now, when you run that commandlet, you can get a couple of different responses back, right? One of the responses might be busy. Okay, well, if it's busy, go get some coffee, okay? Because if it's busy, don't pick at it, right? We don't want you to actually do something because it means it's busy. Maybe you're already upgrading another upgrade domain somewhere. So the fabric is busy right now. If you try to do something at this point, you could cause a service outage. So if you get a response of busy, wait, right? If you get busy 3 times, so you've waited 10 minutes, you waited 10 minutes, you waited 10 minutes, you've got 3 times busy, well, now the reason you have 3 times busy might be because you don't have enough active front ends to be able to maintain quorum if you were to take one more server offline. Was there a question back here? No? Good? Okay. Yes? Is System Center aware of this? That's a great question. My guess is no, but I can certainly take that as an action item and find out for you. This is also a great reason why you don't turn on Windows automatic updates on your front-end servers. Yeah. Or if you do that, make sure that you're on vacation. So when Patch Tuesday comes around, you're on vacation, right? If it's ready, then you follow the drain patch restart procedure, right? So drain the connections, stop CS Windows service graceful, to drain the connections on that front end, apply the patches, right? While you've got the services stopped, patch it for Lync, patch it for Windows, patch it for whatever else you need to patch it for. But while you've got it out of service, patch it, because as soon as you restart it, it's going to come back into the pool again, right? So this isn't like, like an F5 where you can say, well, this guy's out of service until I tell it to come back into service. When it reboots, it's coming back to life. And it's like, and you don't want it to come back to life and then find out you've got to do Windows patches, and now you have to drain it and do all that nonsense all over again. Wait. Patience was never a strong suit for me, which is why I find it entertaining that I actually enjoy working with the fabric. But you have to be very, very patient. If something is not happening, please wait. Because if you start picking at it or you start deciding, well, that's not working, let me reboot this one. Well, let me reboot, you will get yourself into a state where nothing will want to start because the fabric will basically lobotomize itself and go, I don't know what you're doing, so see you. And it just, the services just don't start. So reboot the box and wait, right? When you run get CS pull upgrade ready in a state, it will tell you when you're ready to move on to the next upgrade domain, okay? Now, what about those pesky 2-node front-end servers? I have people come up to me all the time that say, when I'm doing this deployment and I've got to have a minimum of 3 front-end servers for like 2,000 users. That sounds like overkill. Why are you requiring me to have 3 front-end servers? Nobody requires you to have 3 front-end servers. You can have 2. You can have 1. Now, we still support it, but we don't recommend it. Well, why don't we recommend it? Well, obviously, it's optimal to have 3 or more because you're going to have up to 3 copies of your data, right? So 3 front ends gives you 3 copies of your data. 2 front ends, not so much, right? If you stop the Lync services, there are fabric services that are running on the box too. So just stopping the Lync front-end services doesn't take the fabric out of the picture, right? Lync is living on top of Windows Fabric, right? So when you stop the front-end services, the fabric services are still running. They're still maintaining quorum, right? So don't think that if I just stop the front-end services, oh, well, I don't, quorum. Well, yeah, it's still maintaining quorum because the Windows Fabric services are still running. Now, why do we not recommend 2 from an operational perspective? Well, because it's tricky. Because think about if I'm going to do patch management against these guys, right? I've got to be very operationally mature to ensure that I take these systems offline in the correct order and I bring them back up in the correct order. Or I'm going to end up and introduce an outage into the environment. Case in point, if I decide, you know what, I've only got a 2FE pool. My SLA says that during patch windows, I can take the service offline for 2 hours. I'm just going to, banzai and patch them both at the same time. Totally fine, as long as you patch them both at the same time and you reboot them both at the same time. The fabric will be happy, and it'll come back to life. If you decide not to do that, and you patch server 1, and then you take him offline, and then you patch server 2, and then you take him offline before server 1 comes back up, bring them back up in the reverse order. Bring 2 up first, then bring 1 up. The reason you have to do that is because 2 was the last guy that wrote data back into the blob store about the state of the fabric. So if 1 comes back up before 2 does, he's got old data. And he's going to go, oh, something's not right, and then starting, calling Premier, it's not starting, right? So we don't want to get into that state.
If that happens, can you shut them both back down and bring them back up? Or?
Yeah, if that happens, you can power them both off and bring them up in the reverse order properly, and it'll sort itself out. Absolutely. The problem that I see people get into, one sec, I'll get to that. The problem that I see people get into is they bring them up in the wrong order, and 1 doesn't start, so then they try to leave 1 up and bring 2 up, and then 2 doesn't work, and then they take 2 down, and they start just kind of bouncing things around, and the fabric just gets all, and then you end up doing things like resetting the state of the fabric, which we'll get into in just a bit. Yeah?
What does same time mean to you? Within seconds, within minutes?
Yeah, same time to be means that you're like this, and yeah, and you press the got it, yeah, it's, no. No, same time means, within minutes of each other. So basic is what, the time interval? No. All it said, I took this straight from TechNet, at the same time. So your mileage may vary. So, yes?
On the conferencing pools, at least from what I read, it said they only recommend 2 servers. So that kind of goes against the Windows Fabric.
What do you mean by conferencing pools? Because in 2013, we don't have separate conferencing pools. It's all brick model. Everything's all the same. Yeah. In 2010, we had the ability to separate out AV conferencing. Is that what you're talking about? Oh, you're talking about the large meeting thing. Yeah, large meeting thing, different, because the only thing that's running on that is you've got one dopey user that's on there. Oh, sorry. You got one user that's on there that's your, the organizer of the large meeting, and there are no other production users on there. So 2 is fine. Yeah. I mean, I probably shouldn't say this since I'm recording, but whatever. Oftentimes, what I've ended up doing with some customers is just doing paired SEs for the 1,000-user, thing, because having multiple in there, we're only ever going to use 1 anyway. So as long as you don't need that, oh, it failed in the middle of the conference, get everybody over to another one, then, you can go that route. So, yeah, so if you're doing a 1,000-user thing, 2 is fine. Because this really doesn't come into play because you don't have a large number of users that are hosted there. You only have the resource accounts that are there. Okay, so some commandlets. Like I mentioned before, it's a 400-level session. If I show PowerShell, it's automatically a 300-level session, right? So I've passed the gate to be 300 level. So that's what one of my colleagues told me. So, and I'm going to show you some logs in a bit, so that'll get it to 400 level. Life's good. So, taken care of. Get CS user pool info, great commandlet to run. Lets you see the primary, the secondary, and the additional secondary. In this case, right, I actually happen to have these pools paired to each other. So you can actually see backup pool machines or pool B2 and pool B1. That's part of the pool pairing. We'll get to that in a minute. More PowerShell, right? Get CS pool fabric state, get CS pool upgrade readiness state. We looked at those already. These are more for reference for you. And now the fun one. Again, my definition of fun. Reset CS pool registrar state. The documentation on this is interesting. because we kind of tell you what the commandlets are and sort of what they do, but we don't really tell you when to use them, right? So a lot of times you'll see things like, oh, it's not working right. Run reset CS pool registrar state with quorum loss recovery, and that'll fix it. Only if the routing groups are in quorum loss. I mean, if the front-end services aren't starting, then quorum loss recovery may not help you, right? It all depends on the situation, which I'll cover. So you have full reset as one of the options. You only need to run this when actual changes happen to the cluster. Like I went from a 1 FE pool and I added FEs to it. I went from 2 FEs in the pool and then I added more to it. I went from any number down to 2. I went from any number down to 1. Or any kind of upgrade domain changes happen. That's when you need to run the full reset option. Very important, if you're in Topology Builder and you build a front-end pool of 1 or a front-end pool of 2, and then you add more than 2 total, you will get an indication in Topology Builder. We must run full reset because we've got to basically make a change to the way the fabric is operating. If you just do the typical next, next, next finish, and then you hit publish, what happens? We run that command right when you hit publish. Down goes your pool. Because full reset restarts the services. So there's a little checkbox there that says, check the pool that you want to run the full reset command on. You probably don't want to check that unless you're actually expecting the services to restart right now, right? So again, yet another reason why we recommend if you start with 3 or more, you're never going to encounter that situation. You'll never have to run that full reset after you add a 4th or a 5th or a 6th front-end server to the pool. Quorum loss recovery. We've got a replica set or replica sets that are in quorum loss. We need to tell the fabric a little kick in the pants. Please place these somewhere else. That's quorum loss recovery. I'll show you that in a minute. Service reset is just what it sounds like. Restart the services. If you simply run reset CS pool registrar state and hit enter, it will do service reset, which will restart your services, which may not be your desired outcome. And then machine state removed is pretty obvious if you removed a server from the pool, or the server had a massive, somebody released the magic smoke out of the back of the box, right? When you release the magic smoke, the box stops working. You can do machine state remove to get it out of the pool so that the fabric is aware of that. Now, I've highlighted in red here, these guys restart services. They will cause an outage, more than likely. It may not be an outage for everybody on the pool. It may be an outage just for the people that are in a particular routing group, but you probably will cause an outage. The yellow one here, the quorum loss recovery, doesn't restart any services. But it's a very important commandlet, as we're going to see in my screenshots coming up here. So troubleshooting. If the service doesn't start, if it gets stuck in the starting state, check the obvious first. You have at least 50% of the pool, or 85%, if you're doing a cold boot. You'll know that you're having a problem too, by the way, because you'll look in Event Viewer. Don't forget about Event Viewer, by the way. Very, very beneficial. Look in Event Viewer, and you'll see an event in there. Server startup is being delayed because Fabric Pool Manager is initializing, or is being delayed because it's attempting to place routing groups or something of that nature, right? There are instances, again, where when we do routing group placement, if it's a large routing group and there's a large amount of data, it can take up to an hour for the Fabric to place those routing groups, right? Bigger than small. That's what I mean by large. I'm sorry. It's the last session. I'm sorry. It's a great question. What do we mean by large? There isn't a defined number or a threshold for me to be able to say, well, large would be anything over X. Essentially, what it's been to me hasn't really been more about user count. It's been about the amount of data coupled with the user count. So environments that I've done where we've got 60, 70,000 users on the pool, right, up into that range, you're getting into 30, 35 minutes or so for placement for these things to happen. That's not large. My lab has 11,000 users, and I never had to wait an hour for anything to be placed. So, yeah, I don't consider that large. I don't think the Fabric considers that large either. The key point, though, is if you're seeing that message in Event Viewer and you're thinking to yourself, this isn't really that large, right? I'm wondering if there's something else going on. Go and check to see if the replica sets are in quorum loss, right? Because Event Viewer will tell you we're waiting to place this, but if it's in quorum loss, we'll never place it. So you'll just keep refreshing that and be like 58 minutes, 59 minutes, it should go now. And it's still sitting there not working because it's in quorum loss. It's never going to place it, right? So if you're seeing that and you think it's longer than you might have anticipated, check to see if the routing group is in quorum loss. I'll show you how to do that in a couple slides here. All right, so what does it look like on the user side? Let's get a little bit out of the weeds here, come up for error, and then we'll dive right back in. Right? The primary copy goes offline. So here's my user from my lab, good old Amy. She's signed in. Get CS user pool info. There's her 3 copies. A3 is the primary, A6, A1. Fantastic. So now I went to A3 and I stopped the services on A3. Right? This could be a typical patch management scenario, right? I'm ready to drain the connections that are on A3. Well, maybe I forgot the graceful parameter, and I stopped the service. Well, her client goes into a reconnecting state. Very quickly, by the way. It was pretty fun to get that screenshot because it kind of signs out, signs in to the point where if you're really not paying attention to it or not staring at it, you probably wouldn't have noticed it. So I kind of had to do one of those like booting the server. I kind of had to have the screenshot. And it's like, got it. Yeah, it's great. So, so her client goes into this sign-in state, and you see I ran get CS user pool info. One of the secondaries gets promoted to a primary. Within a few minutes, redistribution. In this case, we redistributed to A2, A6, A1. That's great. Life is good. But what's going on the client side? 400 level. Woohoo! We're in a UCC API log, right? We're digging in the log here, and I'm seeing in Amy's log that she's trying to sign into the pool, and I'm getting 2 contact records back. One that says pool A3 with a Q equals 0.7, that's my primary, and then pool dash B with a 0.3, that's my backup, right? Because it's pool pairing. But pool A3 was the one I took down, right? So her client's trying to connect to A3, and she can't connect to A3. And that's why her client looks like that, right? Her client looks like this, as you see on the left side, because she's still trying to connect to A3, and A3 is offline. So I'm trying to do this register. Now, the fabric gets updated, right? Picks the new pool member that we want, which is A2 in this case. And now when I do a register to the pool, I get a response back of, oh, no, you're on A2 now. Okay, A3 is not your primary anymore. A2 is your primary. Sweet. So now I get this information as my primary, and boom, I'm signed back in. Right? So you can pretty easily trace this on the client side, and you can see, she's kind of stuck in this connecting state. What is she trying to connect to? Well, you go look in the UCC API log file, you look for the register that she's trying to do to register to the pool, and you'll see in the response that comes back who we're telling her to register with. In this case, now we've got the correct server, which is A2, because that's the new primary that was promoted. What if that was a 2FE pool? That was a 6FE pool, by the way. So what if it was a 2FE pool? You know, I've heard those things are bad. Does it behave any differently? No. Still works the same. Right? The only difference, of course, is I've only got 2 servers here, right? And I take one offline, and still works fine. Still works fine. Okay, the reason that little asterisk is there is because of a undocumented feature that we have when you have a 2FE pool and you have a SQL mirror on the back end. When you have a SQL mirror, you have the primary and you have the replica, right? If you have a 2FE pool and your databases are running on the replica and you lose one of your front ends, we go offline. Because we can't maintain quorum, because the databases are actually owned by the secondary SQL mirror and not the primary SQL mirror. So that's why if you look at our documentation when we tell you to do patch management, the first thing we always tell you is if you are using a SQL mirror, make sure all of the databases are on principal. Right? Get all of the databases on principal first, not on mirror, on principal first. Then go ahead and do your patching. Because if the databases are on mirror, specifically if the RTC XDS database is on the mirror, and you take down one of your front ends, the other front end will lose quorum. That's something that's slated to be addressed in an upcoming CU. But it's just a little corner case that you need to be aware of. Again, another reason if you weren't doing a 2FE pool, you wouldn't have that problem. Yeah? So the question is, why is it that there's always 3 or 4 databases on the mirror? I don't answer why questions. Yeah, I don't know. No, I mean, honestly, I don't know. And there's a lot of reasons that could happen, and that's certainly something we can take offline. But it is important to know, I have a section coming up on mirroring here that I need to kind of get to quickly, is when you get into a mirroring state, you don't have to take all the databases from the primary to the mirror, right? You can do just application databases like RGS and so forth. You can do the CMS databases. You can do the user databases. So it's possible you could get into that kind of a state depending on maybe an admin ran a invoke CS database, failover or something. So we can talk about it offline. All right. Yes, sir. Nope. Only applies to a 2. Yep, which is why if you follow our guidance of 3 or more, you'll never have the problem, which is why it's not quite as high of a priority to fix. What happens if they all go offline? What if all my copies go offline, right? So there's my user. There she is, A4, A5, A2. Her routing group ID, as you can see there, that's the GUID of her routing group ID. So now I go into Hyper-V, and I select those 3 VMs and turn off, right? Because I'm that kind of guy. What happens? Well, what you would expect to happen. She no longer has any copies because the primary and the 2 secondaries are gone. She's here. She will never come out of that. All of the users that are in that routing group, bye. You'll eventually come out of that into reduced functionality mode, but it takes a really long time. Longer than I said patience is not my, yeah, I didn't wait long enough to get that screenshot. It's like, not happening. So I asked earlier, how do you find out that these things are in quorum loss, right? We get this concept that says, well, the routing group's in quorum loss. Yeah, thank you, Mr. Captain Obvious. How do I figure out that they're in quorum loss? On the right side there, the commandlet that I ran is the same get cspool fabric state that we talked about earlier. You can see right here, service, these are the replica sets. These are the replica sets, has no primaries. That means quorum loss. Check it out. That's her routing group ID. It started with 8EC, right? Has no primaries. These 4 routing groups are in quorum loss. Anybody that is a user that's part of any of those routing groups, you're not getting anything. You're not signing into Lync right now. This is how you know that the routing group is in quorum loss. Great. Help. How do I get out of this state? Oftentimes you'll hear people say, oh, well, just reset the fabric state with the full reset and reboot servers and just, you're going to make it worse. Okay? You're going to take the outage that was affecting 1,000 people and have it affect 20,000 people. Okay? Don't do that. Just run this. Quorum loss recovery. Reset CSPOL registrar state, reset type, quorum loss recovery. That instructs the fabric to go out and see, who are the owners of these routing groups? Yeah, what do you know? They're not there anymore. I guess I better place them somewhere else. That's what quorum loss recovery does. You are instructing the fabric to come out of that infinite wait cycle and say, no, I know those servers are offline, and I know you're really optimistic that they're going to come back, but they're not, right? At least not anytime soon because my VP is yelling at me, and I don't want to have to update my resume. So go ahead and do quorum loss recovery, and the system will go through and realize, those computers are offline, okay. I know what those guys were supposed to be doing. I know they're not there. I'm going to place these routing groups somewhere else. And voila. I placed them somewhere else. I no longer have any, has no primaries, replica set problems here. You can see in the top right, I did a get CS user pool info for Amy again. She's on 3, 6, and 1 in this case. And boom, she signed back in. Nothing to it. So I'm always entertained by responses that say, run quorum loss recovery. Okay, but only if there's something in quorum loss. Otherwise, quorum loss recovery is just going to be a great command that you run that does nothing. So maybe check to see that they're in quorum loss first. Yeah. Well, so in this case, first of all, when I run quorum loss recovery, the other users that are doing their thing, they keep on trucking. They don't notice anything, right? Life is good and nothing's happening for them. The fabric will now take into account, okay, there's 3 less servers for me to place on, so I'm going to try to distribute, and it may, as a result, shift some secondary copies around for the other folks, but it's not going to shift their primaries around most often because it doesn't want to cause an outage for those folks. Yeah, fabric's got to take that into consideration. Yep. Sweet. We made it through front-end HA. Sweet. Any questions on that? Everybody's still with me. That's good. We made it. I enjoy that stuff quite a bit. Like I say, I don't get out much, but I enjoy that kind of stuff. And there's not a lot of clear documentation on it, so I kind of like to bring it to light. So yeah, question. The question is if there's an SBS, does it work any differently? No. Yeah, same idea. It's just another routing group. It just happens that all the users are on that SBS are in one routing group, but it's the same deal. If that one routing group loses quorum, then all the people that are in the SBS are in reduced functionality mode, and then when you reallocate it, they'll come back to life. The advantage, at least for the SBS, is they'll more quickly go into reduced functionality mode, whereas the other guys just kind of sit there at connecting forever. Because as far as they're aware, the pool is up, but they have no copies. So they have nowhere to go. So, yeah, one more question, then I got to get to the next section. Yeah.
So when one of the pool is down an SPA, each one gets the pool. So what happens to that SPA?
Cover that in a little bit. All right, back-end stuff. SQL. Woo! Mirroring. We like mirroring. Mirroring is all about being able to have up to 3 SQL instances, a primary, a mirror, and a witness, and allowing us to have synchronous replication between the database that's on the principal and the database that's on the mirror. The witness is simply there to provide arbitration, right? Same as we talked about before. You can't have an even number of systems and maintain quorum and maintain automatic failover. Now, in the mirroring case, if you deployed this with a principal and a mirror but no witness, it'll still work. It's just if the primary goes offline, you have to manually activate the database on the mirror. If you put a witness in play, it just happens automatically. So we recommend best practices if you're going to deploy SQL mirroring, deploy a witness, right? The witness does not have to be a full SQL instance. It can be SQL Express, right? So you can just go and load up SQL Express on some old server that you've got out there that can act as the witness. It doesn't have to be a full version of SQL. Now, when you deploy mirroring, in Topology Builder, sometimes you'll get this weird little prompt. Well, every time you'll get this prompt. It may not seem weird every time, but you get this prompt where you're going through the publish of the topology, and it'll say a file share path is required. And the first thing that might come to your mind is, I already have a file share. I defined that when I built the pool. That's not the file share we mean. Okay, the file share that we mean here is a temporary storage location for us to put the backup copies of the database that we're going to use to seed the mirror. Okay, this is a one-time use location. Okay, put it somewhere that is not your Lync pool file share. Don't use that. Don't use DFS. Bad idea. Okay, DFS by default does not allow you to put .back files into a DFS share. Well, what's SQL going to do when we create a backup? Create a .back file. So it's going to attempt to write the file there, and it's going to crap out, and then you're going to wonder why mirroring is not working. So don't use the pool file share. Don't use DFS. Just put it somewhere that both of the SQL servers have access to. Now, when I say both of the SQL servers, I mean the SQL Server service, right? So if that's running under a managed service account, give it access. Use the computer account. Whatever you happen to be doing from the SQL side, make sure those accounts have access to the share. Okay? Because the whole point of this is the primary is going to back up its databases to .back files there. The secondary is going to read them and suck them into the mirror copy, and then it's going to establish. Right? So one-time use, boom, you're done. For reference, these are the ports. Right? These are the ports that we use: 5022 to the mirror, 7022 TCP to the witness. You can see them as mirroring endpoints in SQL if you're that kind of person, you like doing T-SQL stuff. So like I said, I don't get out much. So I like T-SQL stuff, so you can actually go in there and see the mirroring endpoint. The reason I put this here is more for reference, and also the fact that making sure that if there's any firewalls in the way, that you've got these ports opened up. Right? SQL itself doesn't tend to put its own firewall rules in. So if you're using even the Windows firewall on the box, you need to make sure that these ports are open. Otherwise, when we try to provision the mirror, it's not going to work. If you choose to use SQL Express, that's fine, but realize that SQL Express has some defaults out of the box that are going to cause you a little bit of heartburn. First is make sure you turn on TCP/IP, right? Named pipes is generally the default, or shared memory, I should say, is the default that we use because we're expecting just to use it locally, right? But we're not going to use it just locally. We have to have the front end, or the primary and the mirror talk to that witness, so we need to turn on TCP/IP. If you are not using static ports, right, if you're using dynamic ports, which is what it'll do by default, you need to start the SQL browser service. Otherwise, the two SQL servers won't be able to discover this guy, and when you try to publish the mirror, it'll give you an error in Topology Builder. It'll try to create the mirror and basically say, I can't find this SQL instance. And you're like, it's right there. I can ping it. Well, we can't find it because it's using a dynamic port, and the browser service isn't started. Hooray! Support for always-on availability groups. Yay! This was, wow, that was fantastic. With this, like, yay! There we go. Thank you. I love that. It's like, yay! Makes it sound like there's only one dude in here. It's like, anyway. So this was announced in the What's New session a couple days ago, and this basically came directly out of feedback from you guys, from customers, from partners, right? Very loud feedback that said that we want to be able to support always-on availability groups. Why? Because we want more flexibility from an HA perspective. And now, essentially, what we're saying here is you've now got another choice, right? We still support mirroring. We still support clustering. And now we support always-on availability groups. So take your pick, right? We, from a best practices perspective, still lead with mirroring, right? And the reason for that is because Topology Builder and all the goodness that's happening inside of Lync Management Shell, we can control all the aspects of mirroring, right? You don't have to be a SQL guy. You don't even have to open up SQL Enterprise Studio if you don't want to, SQL Management Studio if you don't want to. If you want to build an always-on availability group, okay, now you're going to have to do a little bit of SQL work on the back end. You're going to need Enterprise Edition, right, on the back end if you want to do always-on availability groups. But there's definite advantages to it, right? No reliance on shared disk. No need for a witness, right? So we don't have this witness server sitting out there. You can have multiple copies. You could tag one of them as a read-only copy and run reports against it. I mean, there's lots of advantages that always-on availability groups can give you. And targeted for Q3 of this year, of this calendar year, that's when we're looking to have the support baked in to 2013 for always-on availability groups. And this is effectively what it looks like. Again, this is not, we're not trying to turn you into SQL gurus, but we just want to give you a little bit of a flavor. Looks very familiar, right? We've got primary, secondary, tertiary copies. When we build this availability group, it's up to two synchronous replicas. We can use, depending on if it's even or odd, nodes in the availability group. We can use either file share quorum or node majority. We would, again, recommend here, if you're doing an always-on availability group, that you have at least 3 nodes so that you can do node majority for quorum and not have to use a file share. And yes, you do need Enterprise Edition to be able to do always-on availability groups. Specifically, we need 2012 SP1. That's what we're qualifying for always-on availability groups. So fantastic that you have another tool in the arsenal to use. If you're looking around going, I don't know what availability groups are, it's okay. You don't have to use them, right? But there are certain use cases where it's going to make a lot of sense to use availability groups. All right, we made it out of HA. And now we've got to dig into DR. And we've got 20 minutes, so we're good. DR in Lync is provided by a concept called pool pairing. Now, there is data that's being replicated from pool 1 to pool 2 and pool 2 to pool 1. This has absolutely nothing to do with Windows Fabric. Windows Fabric is not involved in the replication of this data or any of that nature. It's the Lync backup service that does the work. Okay, so we have to clarify that because I see posts in community groups and things of that nature that confuse this issue and start talking about pool pairing in the context of Windows Fabric. Nope, Windows Fabric is all HA, all happening inside of a site, all happening inside of a pool. Right? Pool pairing is driven by the backup service. There is a single master for that data. It's the blob store for the pool, right? The backend SQL instance of the primary pool. That's the master copy of the data, right? Because think about it. The front ends, right, have subsets of data for respective routing groups, right? But where's the one place that has all of the data for all the users on the pool? The backend SQL store. So that's the primary. We still have VoIP automatic failover. That has not changed from 2010 to 2013, meaning when you pair these pools together, now, refresher, pairing the pools together is 1-to-1 reciprocal. All right? So pool 1 gets paired to pool 2, which inversely means 2 is paired to 1. That's it. Right? You can't do A to B, B to C, C to A. No, 1-to-1, done. Sorry? Always. The VoIP automatic failover is there for you. So when I pair 1 to 2 and 2 to 1, we automatically have the primary backup registrar relationship, just like we did in 2010. That's automatically there for you, and that still works the same. So if I'm a user that's homed on pool 1, it's paired to 2, pool 1 takes a dirt nap, my client signs into pool 2 because it's my backup, right? You remember you saw in the log that was the 0.3 of the register that I did. I go to sign into the backup, and I will sign in reduced functionality mode, just like I did in 2010, which means voice still works, but I don't have my contacts, I don't have presence, I don't have any of those extra modalities, but voice still works. That doesn't change, right? What changes now is you have PowerShell commandlets that you can run to invoke the failover of the rest of the modalities from pool 1 over to pool 2. So now I can say, ooh, pool 1 failed, and it's not coming back anytime soon because it's kind of a crater over there. So I'm going to invoke CSPool failover and instruct Lync, hey, everybody that was on pool 1, they are now going to be serviced all modalities on pool 2, and will light up their contacts, presence, conferencing, the whole bit, right? That is a manual process. It should be a manual process. I've had people ask me, can you automate that? Sure. Why would you want to do that? It's a DR scenario. I, as an admin, don't want DR happening automatically. I just don't, right? I especially don't want to text at 3 in the morning saying, data center 1's offline, we failed all your users over. No, I don't want that happening to me. Okay, I want control of that because guess what? This might be step 74 in my DR plan. I don't want it happening out of sequence, right? I want it happening right after step 73. So I want control over that. It's manual. So the backup service does the work. It's the workhorse, right? When you pair pools together and then you bootstrap the front ends, we'll install the backup service for you. It is responsible for syncing the user data and the conference content and all that good stuff between the respective pools. This happens by default every 2 minutes. You can change it to whatever you want, but it's every 2 minutes, right? So the idea is it's not synchronous, but it's pretty close, right? Every couple of minutes, we're shuttling data over incrementally from pool 1 to 2 and vice versa from 2 to 1. I'll show you what the process looks like, but effectively, we're batching it in zip files, right? So we're extracting the data from the backend SQL instance, we're packaging it up and compressing it in a zip, putting it on the pool file store, shuttling it over with SMB, and sucking it into the backup pool. I'll show you that in a second. I was waiting for somebody to ask me that. The question is there any guidance on bandwidth between the two pools? No. And again, the reason there isn't is because the amount of bandwidth that's required is directly proportional to the amount of data that you have, and it's only ever going to be that initial sync, and then everything else is going to be deltas. So it's kind of like the amount of time it's going to take me to then figure out what that that first one is. It's done already, and now I'm back into the incremental mode. So yeah, we get asked that a lot. There isn't any formal guidance that I've seen. But again, the expectation here is if you're doing pool pairing, these pools are in the same world region, right? So we're not expecting that a pool in the US is being paired to a pool in Asia. We're not expecting that, right? And if you think about it, I don't necessarily know that I want my users in the US going all the way over to Asia for conferences in a DR type scenario. Not that you can't, but that's not how it was originally built. So when the changes are imported, the zip file gets removed. There's a cookie. It's returned to the source pool in the form of a high watermark. At the next synchronization cycle, we're going to use that cookie, right? The source pool is going to use that cookie to be able to say, that's where I left off. It's like a bookmark, right? That's where I left off. Okay, I'm going to signal and start importing changes from there. You can run backup CSPool or invoke CSPool failover to basically poke the backup service to look for changes and send them on its merry way. So if 2 minutes is just too long to wait, you can kind of poke it with a stick if you want. And then this is happening from pool 1 to pool 2, and then the exact same process is happening in reverse, right, from pool 2 to pool 1. So it's a unidirectional operation, right? So 1 sends its changes to 2, and he imports them. And then 2 sends his changes to 1, and he imports them, right? Nobody pulls or anything. It's always the backup service is taking the data and giving it to the other pool and then signaling, hey, dude, you got something to import. And then he does the reverse. This is what it looks like on the file store. So the backup service writes the data out to the pool's local file store. So I'm pool A, right? That's my one. Pool A's file store you can see on the left here. This is the file share, the backup service, the backup store. There's a temp folder here. That's where we put these zip files, right, into that temp folder. And then we use good old-fashioned SMB to copy the data from the temp folder that's on pool A's file store into pool B's file store. So this file gets copied over into pool B's backup store, and then pool B is signaled, hey, there's some changes out there for you to process. And he goes out to his local file store, and he looks at the cookie, looks at the high watermark, pulls the zip file in, and puts the data into the back-end SQL database of pool B. And we're off and running. And that same thing happens in reverse, right? So all of the magic of this is happening through file transfers between pool A and pool B's file stores, respectively. Well, here, as far as firewalls and ports are concerned, I mean, that's standard SMB. So that's, 445 TCP. No, it's not. The question is it each front-end server doing it directly? No, there's one of the front-end servers in the pool is delegated as the primary that's effectively running this. And, of course, if he were to go away, then somebody else would become the primary. Nope. No, they all have, you would not see, you wouldn't have any indication in services or anything like that. You'd have to dig into PowerShell, and I've forgotten what the command is off the top of my head to see it. Yeah, you can see it in PowerShell, but all the services will be running. So if you just looked at services, you wouldn't know who's doing it. Let's not forget about our friend, the central management store, because that was another big bonus of being able to do this pool pairing concept, is to give you a level of protection for CMS, right? CMS, the central management store, that's a pretty critical component that we have in the Lync environment. And especially in the DR world, right, we want to make sure that if the primary pool that we lose also happens to be the active CMS, that we allow the secondary pool to take over that level of responsibility. You can do that with invoke CS management server failover. So the pools are paired, we're protecting CMS automatically for you. So pool A is the primary, he's the master, life is good, and then dirt nap. Invoke CS management store failover basically instructs this pool, hey, you're going to take over now, and you are going to be the CMS master, right? And then pool A comes back up and he goes, okay, I've got to resync, and then you can move it back if you so desire. Pretty important bullet in here in the middle. You do pool pairing between pool A and pool B, and pool A was CMS. By virtue of doing that pool pairing, all of the computer accounts that are in pool B get added into a group called RTC config replicator. This is the group that's given permission to the file shares that we use for XDS replication. What happens when you put a computer in a security group? Do those permissions take effect immediately? No. They take effect on reboot. So let's say that you pair the pools together, and then you're like, pool pairing's done. Let's test this thing out. Boom. And you take down that CMS, and you invoke CS management server failover, and it throws an error. Error 5. Access denied. And then you start digging around, and you're like, well, the computer accounts don't have permission. I'm going to check this. I'm going to set the permission. Okay. Pool pairing. Those computers are in RTC config replicator. Reboot them so that they pick up their membership. Then you can go ahead and run the failover, and it will work as expected. So don't get trapped with that permissions issue when you configure pool pairing. Right? Obviously, don't just reboot those servers because I said so. Proper outage window, all that good stuff. Yeah. Brian said to reboot it. Yeah, I don't want to get any I don't want to get IMs about that. Other things to think about when you're doing DR. A GeoDNS. Yeah, that's a good thing to think about, right? Because pool pairing certainly helps from the Lync perspective, right? But you still have things like Lync Discover. You still have your meet URLs. You still have your dial-in URL, right? You still have these common URLs that you have to be able to access. Well, pool pairing is not going to help you with that, right? Because if I have to hit linkdiscover.contoso.com, I'm going to query DNS for that. And if the only DNS records point me to pool A and that data center craters, how do I get link discover to go to pool B. Well, I have to go manually update DNS, right? That's fine. If that's part of your DR plan, totally cool, right? But if that's not part of your DR plan and you're expecting it to just sort of work, you're going to be surprised when it doesn't, right? So you could look at something like GeoDNS, right? And this is not a Lync solution, right? This is part of your DNS provider, or you can get traffic management, things like F5 and whatnot that'll do it for you. But basically be able to say, hey, I happen to be on the west coast of the US, so when I query for linkdiscover.contoso.com, I'm going to go to the San Francisco data center. But I happen to now travel to Florida, and when I query for linkdiscover.contoso.com, it directs me to the New York data center. And in the event the New York data center goes offline, the services realize that, okay, that's down, so I'm not going to offer that. I'm just going to send everybody over. That's what GeoDNS would do for you. So you want to look at that specifically for your simple URLs, the link discovery URLs, meet URLs, and so forth, because they're the ones that you need to have available across the multiple data centers, right? And if you decide not to do GeoDNS, that's fine. At least make sure that you have, a strategy for changing DNS records or getting it, flipped around the way you want. Don't just put multiple DNS records in there at the same weight. That'll be entertaining. The poor man's DNS load round robin, don't do that. HTTPS doesn't like that. So the question is, how do we know if the area went down? I mean, you can, if you're using load balancer or something like that, they can post and get and go against the URLs and see if the service is alive or not. Well, I mean, the typical URLs, the simple URLs, are the ones you're going to want to test, right? If you're using SCOM, you can do tests against the external web services and things of that nature. But I mean, to me, those simple URLs are the most critical ones, right? Because the other ones are all kind of pool specific. So you can still test them, but from a DR perspective, it doesn't really apply. That's really just more making sure the site is up, kind of deal. Yeah. From an edge perspective, you can deal with that. I know I had a question earlier that was asking about edge. I don't talk a lot about edge in here, but the idea would be you'd have multiple data centers, you'd have multiple edge. And if this environment went down, you may have to adjust your federation route and whatnot to go over the second one. But all that has to come into play with how long do you think the outage is going to be, and maybe part of your SLA says, you know what, when we're in this reduced state, federation just doesn't work, and you wait for it to come back up. So. All right, PChat, I'll come back to you in just a sec. PChat uses stretched pools, which is entertaining because it works, but I just hate the fact that there's stretched pool, because then people go, well, I can stretch my persistent chat pool. Why can't I stretch my Lync pool? I want to do the stretched pool like we used to do in Lync 2010. No, you don't. The fabric will hate you if you do that, so please don't. But persistent chat does operate on a stretched pool model, right? Because persistent chat does not use Windows Fabric, right? Persistent chat is its own pool. It's its own little creature, right? So when you deploy it, you can have up to 8 servers in a persistent chat pool, and you designate up to 4 of them as active and 4 of them as passive, right? And you determine that based on the latency and speed of link between the 2 data centers. So high latency, low bandwidth, you would likely have 4 of them active here and none of them active here, right? Low latency, high bandwidth, you'd probably do 2 and 2, right? 2 active, 2 passive, 2 active, 2 passive. So they could load balance. All depends on the connectivity between the sites. To protect the back end, you have to do log shipping in SQL, not as elegant as pool pairing for Lync. So you have to do log shipping to get the logs, the SQL instance from data center A over to data center B. It's a pretty complicated concept, and it's not quite as streamlined as we have on the pool pairing. But it certainly does work, and it's pretty well documented out on TechNet. All right, I got to wrap up here with management of DR. Get CS backup service status is a commandlet that you can use to see what's going on with the backup service, right? And when you look at this, you'll actually get some interesting responses in the export status, import status state, right? So I put a little table here that shows what we're expecting to see, and if we end up getting something that we didn't expect to see, like not final state, what does that really mean, right? So here I can see obviously things like export of final state, life is good, right? But then you take a look here, and there's one on the right there that says not initialized, right? And that's for central management.cms master. It's under import status, not initialized. So you look at the chart and you go, this status is not yet initialized. That was helpful. Usually it's the state before it starts the first export. Well, in this case, that'll never change in this particular screenshot. Anybody know why that is? Yeah, because the pool that I ran this commandlet on is the CMS master. So he has nothing to import because he's the master. Pool B will never send any CMS data back to him because I'm the master. I don't want his junk, right? I've got the good stuff. So my import state will always say not initialized. Likewise, if I run this against pool B, the export state for CMS will say not initialized because he has no reason to export CMS. He's not the master. Woo. Okay, so just because you see not initialized doesn't necessarily mean there's a problem. Oftentimes it does. But if you happen to see it under CMS, take a moment and say, I wonder who the master is. Right, get CS management store connection. You can see who the master is. Oh, yeah, he's the master. Well, I would expect his import to be not initialized, and I would expect the other guy's export to be not initialized. More reference of commands, backup service config. If you want to see and change the interval, so maybe 2 minutes isn't to your liking, you want it to be 10 minutes or an hour, that's fine. You can make those adjustments as necessary with get CS backup service config. You can use get CS backup pool relationship to see who's paired to what. Right? You can use topology builder for it too, but hey, it's more fun to whip out PowerShell. And invoke CS backup service sync if it's not been 2 minutes or maybe it's not been 30 minutes as you've configured it and you want to implement a sync, you can. Just remember that that's a unidirectional sync, right? So if I run that on pool A, it'll invoke the sync from pool A to pool B. If I want to sync the other direction, I need to go and say invoke CS backup service sync for pool B so I can tell pool B to send its changes to pool A. Right? So just running that isn't going to make them both sync. Right? It goes one direction and then you sync it in the other direction. And no, not the horrible band. Was there a question back there? Okay, the RTO and RPO for pool pairing is engineered at 30 minutes. I mean, that's what it's engineered for. So, I mean, there it is, 30 minutes. Yeah. So the DNS entries for the resilient pool, are you talking internal DNS or external DNS? Okay, so for external DNS, you're not going to do anything different because the pool entries are all pointing to your reverse proxy, which are specific to a site. And if you go from pool A to pool B, you're going to be using pool B's external web services, so there's nothing specific you have to do there. As far as things like SRV records, Lync 2013 uses Lync Discover by default, so SRV records are a fallback for us. This is why I say you should do GeoDNS for Lync Discover, because that will give you what local edge server you need to use. So in the event that it fails over and you query Lync Discover, it will say, hey, you're on pool B now, you need to use edge B instead of edge A, and you can connect in. If you forgot to do Lync Discover, you could still do the traditional, multiple SRV records, right, and put SRV to edge 1 and put an SRV to edge 2, and in the event that edge 1 goes down, then the SRV record would take you over to edge 2. Okay? Okay. You made it, and I have 2 minutes to spare. That's awesome. I love it, even with new slides. Any other questions, comments, jokes, anecdotes, anything of that nature? It's the last session of the conference. Let's have some fun. Yeah. Yes. Okay, so the question is, what about if they're in a conference? And for the folks that are leaving, please make sure you fill out your evals so that we can get some good feedback on it. As far as what happens in a conference, it depends on what MCU you're using. Right? So it's quite possible that I may be connected to front-end 1, but I might be using the MCU on front-end 3. Right? So in that case, I wouldn't notice a drop in media. I would notice a connection problem to the conference and then repaired connection as the signaling adjusted itself, but I wouldn't notice a drop in audio or anything of that nature. If I happen to have the bad luck of using the MCU on the server that went down, then yeah, my stream is going to disconnect, and when I get the new signaling information, I'll get provisioned back to a new MCU, and it'll reconnect itself to the conference. Yeah, it's all the organizer's resources, that we end up with. So, yeah, if we have bad luck to be on the server that went down, then yeah. And that's why if you're taking it out for maintenance purposes, you always use the -graceful, because it will wait until that conference is done to fully stop the service, right? So it'll make it so that no new connections come in, but existing connections happen, and then when the conference is over, then we'll take the server out of service. Yes? Thank you for bringing that back up. Okay, so you have the SBS or the SBA, and it's using pool A, and pool A takes a dirt nap, and now you fail over to pool B. The SBS is completely unaware of pool failover. It has no concept, so they will be stuck in reduced functionality mode until you bring pool A back up, or until you go back into Topology Builder and reconfigure the SBS to use pool B. Yeah, so it's not a pleasant situation. Yeah, there's no intelligence built into the SBA as far as the pool pairing concept. Doesn't get it. Yes? Sure. Start them all up. But they're all up at the same time, so now... Yeah, so repeat the question. It's if you're doing data center maintenance and you kind of power down the whole thing and you don't have DR and then you just power down the whole data center and make sure you power, you bring the data center back online. How do I bring the pool back up? Just start all the front end servers at the same time. Sure. Yeah, so if they power up one, it's quite possible that you power up one and the others don't come online for an hour after that. Well, the pool's not going to start. And eventually that front-end service is going to stop. So more than likely, if you get into that situation, worst case, you're going to end up with all of your front-end servers booted and none of the front-end services started. And then you start CS Windows service on all 6 of the servers, or however many, all servers all at once. And yep. Yeah, and then hopefully you go back to the data center guys and go, can we kind of rearrange it so that these guys are, because you also have to consider that with virtualization too, right? Which we really didn't get into, but recall now that you learn about how Fabric is, you don't want to end up and put 3 of your front-end servers on one Hyper-V host that has all of your copies, and then somebody powers off the Hyper-V host, and that'd be bad. Yeah, that's no fun. Yeah, so with SQL mirroring, you're saying, can I have some of the databases active on one and some of them active on the other? Sure, you can. We don't recommend it. It's good to keep them all together, and that's specifically, especially when you're in that 2FE world, but there's nothing that would stop you from running, the active, application databases over here and the user and CMS ones over here. That's totally fine. Sure. Yes. Yeah, so in theory, you could do that with CDR and QoE. Yep. Okay, I'm going to wrap it here since I want to make sure everybody had a good time. Please don't forget to fill out your evals. And I'll be around if you have any other questions. Thank you.